Hi guys, BuildZoid here, and today we're going to be taking a look at the Gigabyte Z590 Aorus Xtreme motherboard. Now, before we get into this, Gigabyte did send me this board as well as a couple of the other Z590 motherboards that they've made. So big thank you to Gigabyte for sending over the boards, because that way I can actually test them and also take these extremely garbage PCB pictures myself. But the main thing for me is I have to be able to identify the components. I don't think they need to be particularly legible in the video. Anyway, so yeah, let's get into it. The Z590 Aorus Xtreme is the most expensive motherboard in Gigabyte Z590 lineup, and funnily enough, it is actually cheaper than all of its direct competition. Like this thing's $850. I really don't think anybody should be spending $850 on their motherboard, but the thing is, I mean, the MSI Z590 Godlike is $1,000. And then you have the Asus Maximus 13 Extreme at $899 or $900. So yeah, this is like the cheapest air-cooled flagship motherboard. There's also a water force version if you really feel like, you know, spending pointless, like spending extra money for no good reason. But yeah, so this is sort of this is an extremely excessive motherboard in all ways, including the price tag. It's not really a motherboard I think anybody should be buying, but it does kind of do like everything and has some neat features to it. So let's get into it. Starting off with the rear I/O, we've got the Q Flash Plus button that allows you to update the BIOS of the motherboard without even having a compatible CPU. Clear CMOS button, which I really think with this should have actually been like a safe boot button, or you could have had clear CMOS and safe boot on the rear I/O. I think that would, like from an overclocker perspective, that I think would be better. But anyway, like there's nothing super wrong with this. Below that, you get Wi-Fi 6 E, right? Like that's what it's called. Anyway, you get the new fast Wi-Fi. I don't care about Wi-Fi. You get some Thunderbolt outputs. You do not get a you don't get a display input for the motherboard. So if you wanted to like pass through your GPU through the Thunderbolt ports on the board, as far as I can tell, there's no way to do that. So the only display output you're going to get out of these is from the iGPU, which I question the I question how useful that is. But yeah, you can get a display output out. It's from the iGPU, which I'm not sure is really that useful. But anyway, you do get Thunderbolt function, but for like if you're just hooking up like storage devices or whatever it is that people do with Thunderbolt, it does do that just fine. You get 2.5 gig Intel LAN, 10 gig of Quantia LAN, and then you get a bunch of USB ports for the rest of the rear I/O, as well as an HDMI output for the iGPU, and then you've got your audio over here. Anyway, so that's the rear I/O. Then on the board itself, we have a post code, some voltage read points, an OC ignition button, which will just keep the power supply turned on while the rest of the system is turned off. Gigabyte says this is great for testing water cooling loops. I think that is a terrible idea because if the power supply is on, then you have 12 volts running to all of your 12 volt power planes. The biggest risk with water cool, like the rail that is going to cause the most damage in the case of a water cooling leak is the 12 volt power rail. So like, not really that useful in my opinion, but sure, I still wouldn't use that for testing water cooling loops. Like, in my opinion, you shouldn't have power running to any of your system components while, you know, you're leak testing your loop. Like, your power supply should just not be plugged into anything that you don't, like, that could get leaked on. So, yeah, anyway, but like the original purpose of this is to just, like, there are some uses for this, but yeah, I don't really understand why Gigabyte thinks you'd want to use that for water cooling testing. Anyway, next we have a power button and a reset button. The reset button can be rebound to function as a safe boot button through the BIOS. I've done a video on this. It's extremely useful. In fact, it's my favorite feature of Gigabyte's entire, of the Z590 lineup from Gigabyte, is that they now have safe boot functionality on the reset button. So that's pretty neat. Then you get your right-angled 24-pin power connector. The motherboard is very EATX, and then also consider where that 24-pin is going to stick out to. So case compatibility is something to watch out for with this board. And then moving along to the bottom edge, we've got the dual BIOS control switches. So this being a high-end Gigabyte motherboard, it has automatic dual BIOS. This switch over here allows you to disable that. So you can disable the automatic dual BIOS switching, and then the other switch allows you to choose which BIOS chip you're actively using. Unfortunately, because of all of the sort of aesthetic covers covering up the board, you don't get to see, like, you can't see the indicator, like, there's not an indicator LED for which BIOS chip is active, which I think is, like, really dumb. But then again, like, the thing is, these are all issues that, like, lower-end Gigabyte motherboards don't have because they're not, you know, going out of their way to look like a black blob of aluminum, which, incidentally, if you think all of, like, these cover components all around the board, they might look like they're plastic, but they're actually aluminum, which I think is really, really excessive, but it does make the motherboard extremely rigid. And it also has a backplate. Like, this board has, in its fully assembled state, has basically no flex to it, which could help with, like, really heavy GPUs and really, really heavy CPU heatsinks. Yeah, again, like, I think if you're getting a board like this, you should probably be water cooling your CPU. So that benefit, like, the CPU heatsink benefit is kind of, you know, not really a thing. But it does help with just durability of the motherboard if it isn't able to flex too much, because you can actually do, like, cause damage to the board by say bending the area around the chipset. Can actually break motherboards quite easily. So, but you don't need, like you can achieve that level of rigidity with just the backplate. Like, the front cover is really excessive. There's other motherboards from Gigabyte that do this without going this far, but yeah, so you've also got that. And that basically covers all of the sort of basic features on this board, right? So yeah, I don't really think there's anything missing. You have safe boot, you have clear CMOS, you have a postcode. You even have voltage read points. I really feel like, overclocking wise, there's not really anything extra I could ask for. You also have dual BIOS with actual dual BIOS control. But the thing is, you also get all of this functionality on, say, the Z590 Master, which is way cheaper. Which is, like, a big reason why I wouldn't get this. And if you don't care about having the dual BIOS and you're okay with a slightly weaker VRM, there's also the Z590 Ultra from Gigabyte, which is, again, even cheaper. So, yeah, this board is just like it does. It's not a motherboard that really makes any sense to purchase, in my opinion. Like, this is a motherboard for extreme Gigabyte fanboys, I guess. Like, that's the only way that it makes sense to buy this board. Or if you just have so much money that you don't know what to do with it anymore. That's the other option. Because there's really, like, you can get 99% of the capabilities of this board for significantly less money. But anyway, let's talk about the power delivery. You've got two 8-pin power connectors, which is actually kind of useful when, like, hammering a 10900K, because you can just about max out a single 8-pin with a 10900K. So the second 8-pin, or even with the 11900K, you can pull quite a lot of power on that as well. Yeah, so this is kind of useful for those, but if you're not absolutely hammering the CPU, you only need the single 8-pin. So, so, like, basically, you need the dual 8-pin if you, like, you should know if you need the dual 8-pins, because you're probably, like, running a delidded CPU with, like, liquid metal under the IHS, or a direct die cooling system of some sort. And yeah, so that's kind of that. So not really that useful for any, like, for the application I expect to see this motherboard in. I really don't think the dual 8-pins are really that useful, but they definitely don't hurt anything. It's not like, at least it's not like a low-end board where the VRM would die before you max out the first 8-pin, you know. It's a pretty common thing to see on some motherboards, where it's like you have more power connectors than what the VRM is physically capable of handling. But yeah, not the case here, because the VRM on this thing is absolutely ridiculous. It's not quite as ridiculous as what you have on the MSI Z590 Godlike, but that's mostly down to the fact that Gigabyte is still using a sensible controller instead of a instead of the 20-phase monstrosity that MSI somehow managed to get from Renesas. Like, I still can't believe we now have 20-phase VRM controllers. Anyway, so the way this VRM is set up is that you have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I was like, I wasn't entirely sure if there was a second iGPU phase, and I haven't actually counted yet. But anyway, 20 phase. Like, my notes already assumed that it was single phase iGPU, but it's hard to tell. So 20 phase V-core. Well, actually, it's not really a 20 phase, because what's going on here is you have a 20 power stage V-core, and then Gigabyte is using a bunch of doublers on the back of the board. That's these chips, and then these, and this one, and all of those. And as you can see, there's 10 of those. And those are all ISL 6617s. And so 6617s are doublers, but they're very funky doublers. They're very smart doublers. They can do current balancing, and they can also not double at all, which is the really popular configuration for them these days. Back in the past, you'd actually get motherboards where the ISL 6617s would be running in interleaving mode. On a motherboard like the Z590 Aorus Xtreme, they actually run in synchronous mode. Now, you still get current balancing benefits over just doing, say, what Asus does, where you take a PWM signal and just shove it into two power stages at the same time and kind of hope that they're going to balance themselves, which they mostly do anyway. But yeah, doing it this way is ever so slightly better than not doing it ever so slightly better, at the cost of adding a little bit of delay to the PWM signal. So you get a little bit more efficiency and theoretically slightly worse transient response. I've not actually been able to measure that there is a that the transient response is worse with the ISL 6617 boards, because for Z490, Gigabyte had boards with and without doublers, and the boards without the doublers perform exactly the same as the motherboards with the doublers. So evidently that delay is just not long enough to matter to the overall voltage regulation when running various, the various CPUs that you can put into an LGA 1200 socket. But the thing is, yeah, Gigabyte is not running those in interleaving mode, so you do get like a sort of weird situation where you actually have two well, it'll be a group like this, more like, yeah, I'm gonna go over here because I'm not entirely sure if the grouping is like this or if the grouping is like that. But anyway, you'll have both power stages turn on at the same time, and then they can actually turn off at slightly different times in order to maintain current balance. So that's sort of what the ISL 6617 adds, because otherwise, without the 6617, they'd have to turn off at exactly the same time as well. Now, the reason why the 6617 offers this synchronized operating mode is because it improves your transient response, because you get twice the current slew rate because your output inductance is cut in half. And there's some other interesting benefits to this, like if you look at a non-doubled Gigabyte Z590 VRM, they'll be using like 150 nanohenry inductors per phase. For the doubled Gigabyte Z590 VRMs like this one right here, they actually use 300 nanohenry inductors. So the current slew rate between two power stages on this board, so Intersil calls them channels in this configuration, so we'll just call them two channels. So like this is a channel, right? And this is another channel. And they can be out of phase with each other, but if you're running the 6617s the way Gigabyte likes to use them, they're not out of phase with each other. So you have both channels, like the current slew rate for a channel is the current slew rate of like these two channels combined is the same as like a single phase on a non-doubled Gigabyte motherboard, because they do use higher inductance inductors. However, there's a benefit to using the higher inductance inductors in terms of power efficiency again, because by using a 300 nanohenry inductor, you actually reduce the RMS current through the power stage, which slightly improves the VRM efficiency. So you might see like 5% less power loss with a 300 nanohenry inductor than with a 150 nanohenry inductor, because basically if you have the 300 nanohenry inductor and you look at the graph of the current flowing through the power stage, And actually, this is going to be really awkward. Should I explain this in this video? I'm pretty sure I've done a video explaining this separately, but if you had... Oh, actually, I have two colors, so we're going to get a blue, because I'm pretty sure I've explained this in the past. But anyway, so if you have a 150 nanohenry, so we're going to have the 150 in orange, and we're going to have the light blue for the 300. So if you have a 150, it might look something like this. Actually, it'll look more like this. I'm drawing it wrong. There. You'll have something like that looks like this. So that'll be the current waveform through the power stage, and also I screwed that up. Whereas if you use the 300 nanohenry inductor, it'll look more like this. And because power loss through a power stage is I squared R, if like this peak, the peak current flowing through the power stage is like more bad for the efficiency than like this part right here. So yeah, the minimum current flow on the 150 nanohenry inductors is lower, but the peak current draw is higher, which is why the RMS current overall is higher, and so your efficiency is lower if you use a 150 nanohenry inductor with the power stage than a 300 nanohenry inductor with the power stage. Now, you do also get this benefit if you do what like Asus does, or MSI likes to do it as well. Actually, everybody likes to do this, except, no, Gigabyte has some motherboards that do this as well. Do this too, where you just put your power stages in parallel and feed one PWM signal into them. You also can get this benefit. And the thing is, like, initially you might think, wait, but if the phase, like, well, if the channel has this reduced current slew rate, right, because the current ramps up through it, ramps up and down through it slower, then wouldn't that lower your transient response? Well, it doesn't, because we have two channels turning on at the same time. So you actually get, like, effectively, this brick, when it turns, like this, the two channels when they turn on, effectively they have the current slew rate of 150 nanohenry inductor, but the efficiency per power stage of a 300 nanohenry inductor, which is like a pretty cool benefit that you get by doing this. So yeah, though theoretically you could also do well, actually no. You couldn't really, like, there's other ways to achieve similar effects, but this is just sort of some of the benefits of running the synchronous mode. Is you basically get more efficiency with the ISL 6617s. You also get some amount, like some current balancing going, and then on top of all of that, you get like the same current slew rate as if you had a single channel. So yeah, this is like you basically get an efficiency boost over a like per channel efficiency boost compared to, say, a 12 phase that doesn't use any doublers. Anyway, so that's sort of what's going on with the control scheme for the V-Core, which I haven't even mentioned that the power controller is the ISL 69269, but this is like, this is Gigabyte's controller of choice for, I think, their entire Z590 lineup. I don't think they're using any other controllers, at least not for V-Core. For the minor rails, like your iGPU power and system agent, they sometimes use some other controllers, but V-Core is always on ISL 69269. And this controller works really well. Also, I really don't think, like, as I mentioned, I tested Z490, like, transient response on Gigabyte Z490 motherboards. This VRM right here, in terms of its control scheme with the ISL 6617s and the power stages and the 300 nanohenry inductors, is literally just the same. Like, this is the same VRM as what you had on the Z490 Xtreme, except they've added 6 power stages? Yeah, they've added 6 more channels to it. So previously it was like 14 channels with 7-phase interleaving. Now it's 20 channels with 10-phase interleaving. So you also get less input ripple thanks to the higher phase count, and also technically less output ripple. The thing is, the output ripple of a VRM is just completely irrelevant compared to the transient response. Like, the switching noise from the CPU is so much worse than the ripple from the VRM that you will never, like, if you... if the VRM is idling, you might be, like, if you were using the VRM to power like a resistor, you might actually be able, you'd be able to actually measure the ripple of the VRM. In any real world application with a CPU, the CPU produces so much switching noise that the VRM's output ripple is is basically irrelevant. But the lower input ripple does mean that the VRM puts less wear and, like, less stress on the input filtering capacitors. And on that note, Gigabyte, like this being the Xtreme, we've got tantalums for like half the VRM for input filtering, and then we do have a bunch of regular aluminum polymers in the through-hole packaging for the rest of the input filtering. The only Gigabyte motherboard with a better input filter is like the Z590 Tachyon, which goes for all tantalum polymers instead of any like through-hole capacitors. So yeah, anyway, basically it doesn't really get like for Z490 it really doesn't get better than didn't get better than this VRM for Gigabyte. At the same time, they also didn't have any VRM that was like significantly worse, which might just be the limitations of my measuring equipment. But yeah, so for Z590 it's just like it's more like Gigabyte took a VRM that was really good on Z490 and they just made it capable of handling even more current. So much current, in fact, that I recently did a video with this motherboard where I ran it with no VRM heat sinks, and it still didn't manage to trip over temperature protection. Like, it did end up getting very, very hot, but if you did the same test on a, cheaper motherboard, like, it would just overheat and shut down, or overheat and start thermal throttling, one of the two. This board, you can get away with running it with no VRM heatsink, even in like a zero airflow environment. And if you provide some airflow, it runs at like perfectly acceptable temperatures for long-term operation. And the reason why this VRM can handle so much current, because I still haven't mentioned it, is the ISL 99390 power stages, which we've seen so many times before. They're just super popular, high-end 90 amp smart power stages from Intercell. Gigabyte was using them on all of their Z490 boards, and now they're using them again. There's just more of them. And the end result of having more of them is that the VRM power loss, that's not including the power plane and like the socket power loss, because yeah, it turns out that that is actually very significant. Which, well, the thing is, the power plane power loss and the socket power loss, it depends how much current you're pushing, right? But this is also a motherboard using an 8-layer PCB, so that's just like the power plane on this is larger and like lower resistance just because it has more layers to it. You can't really do anything about the socket power loss, but the socket power loss, like the CPU cooler is taking care of that mostly. Anyway, so the VRM power losses on this are at 1.2 volts output voltage and 500 kilohertz switching frequency, which I believe Gigabyte actually runs this VRM, like for some of these other Z590 boards, they run at 300 kilohertz. I think this one they also run at 300 kilohertz. Just because when I was testing the Z490s, you could like run them at 300, 400, and 500 kilohertz, and I really couldn't measure any like differences in terms of voltage regulation. But anyway, so 1.2 volts, 500 kilohertz, this is what the data sheet is spec'd in. Like, even if Gigabyte is running these at 300 kilohertz for extra efficiency, the documentation doesn't, like, specify how the power stages would behave at 300 kilohertz instead of 500 kilohertz. And the power losses for both the inductor and the power stage, though Gigabyte is using slightly different, like, is using different inductors from what the data sheet uses, so these numbers are a very rough sort of estimate instead of like exactly what kind of efficiency the VRM is getting, but they generally aren't too far off for the actual like efficiency of the power stages and the inductors. So anyway, 200 amps output, you're going to be looking at about 200 amps out. Yeah, 200 amps output. The VRM is going to be producing about 22 watts of heat. Wait, what? No, I'm reading the wrong part of my notes. 15 watts of heat. There, that's more like it. Funnily enough, at 20 amps output, this VRM would be slightly more efficient if it wasn't actually running all of the phases, wasn't running all of the channels, which you can do. Like, depending on how the ISL 69269 is configured, the VRM could shut off extra phases, though it doesn't do that because the efficiency benefit of doing that is very, very minor. At 200 amps, I believe the difference is like 14 watts of heat dissipation instead of 15. And so it's just kind of like, yeah, it's a desktop motherboard. Your CPU is already pulling 240 watts. One more watt of VRM heat dissipation just doesn't really matter. Anyway, so that's 200 amps. 300 amps output current, which 300 amps is about like that is getting any CPU on the LGA 1200 socket to pull 300 amps is very, very difficult without the CPU also running insanely hot. Most of the time I only get like the 10900K I use for VRM testing. Usually it like the maximum I can run into that is around 270 amps. And at 270 amps, it is very, very hot. So, you know, this is kind of like not even like this is absolute worst case scenario. Like you would really want to be like direct die, massive custom loop, that kind of situation in order to be able to push this much current into the CPU. But if for some reason you like if you did manage to push that much current into the CPU, the VRM would produce only about 22 watts of heat, which is not much. And this is the main reason, like, when I did that VRM torture test with no VRM heatsink on this motherboard, you know, I was, I believe, at around 260 to 270 amps going into the CPU. And so that's in between this, like, 15 watts and 22 watts of heat output. And yeah, you can get away with that with no heatsink because that's less than, that's around 2 watts per power stage. Right, and you can still deal with that without even having a VRM heatsink, especially if you have like an 8-layer PCB with massive power planes and like a massive 12-volt power. Oh well, just massive power planes in general, because the PCB will act as quite a heatsink in that scenario. So anyway, yeah, like mega overkill VRM for any kind of ambient use. And then 400 amps output current, you'd be looking at about 31 watts of heat. So now the heatsink is actually like necessary. Past 300 amps, you can't really get away with running the VRM with no heatsink. Though if you provided even the like minimum amount of airflow, you probably could. But anyway, 500 amps output current, this would produce about 42 watts of heat. And 600 amps output current, it would produce about 55 watts of heat. So yeah. Like, this VRM definitely deserves the you know, well, the board, like, a board like the Z590, a very fitting VRM for a motherboard called the Z590 Aorus Xtreme. There's really nothing you could put into the LGA 1200 socket that is gonna, like, be able to max out this VRM, unless you're on liquid, like, the only way you could actually, like, max out this VRM is if you were running, like, Prime 95 on liquid nitrogen. Or I guess Y Cruncher. But the thing is, if you're running, well, yeah, like Prime 95 on liquid nitrogen is probably the only way you would actually get this VRM to, you know, like have like struggle. Admittedly, also you'd be pushing much higher voltage than just 1.2 volts at that point, which would further increase the heat output of the VRM. But yeah, like at that point you would finally really need the VRM heatsink that it comes with. So yeah, mega overkill VRM. It's actually, in terms of like configuration, this is basically the exact same thing that you get on the MSI Z590 Godlike, except the Godlike uses a 20-phase controller instead of what Gigabyte is doing here with the 69269 and then the doublers. So that aren't running in doubling mode, which I still find absolutely like I don't even like, yep, we have doublers, then we run them in synchronous mode, which is like, I mean, at that point, you could just do what Asus does. Because there's really not, like, there is a difference, but there's not enough of a difference for it to matter as far as I'm concerned. But also on a motherboard this expensive, I don't think Gigabyte particularly cares about having to spend a little extra on some ISL 6617s in order to get the double, like, in order to have the extra current balancing. Anyway, yeah, so that's the VCore VRM on this. Like, just ridiculously excessive, but that's kind of what you expect from a motherboard at this price tag. Then down here we have the system agent rail. This is also controlled by the ISL 69269. So the controller on here is actually running as a 10 plus 1, which I think I actually suggested that, like, because Gigabyte on the Z490 boards, are like, they were running the 69269 as a 7 plus 1 plus 1, or as a 8. No, they ran it as a 6 plus 1 plus 1, and they ran it as a 7 plus 1 plus 1. And at the time I was like, I'm surprised they didn't go all the way to 10 plus 1 plus 1. Well, now they did. They're at the, like, don't go past, like, we're running out of space on the board for VRM. We really don't need more power stages, okay? Like, this is too much. Oh, and I guess I forgot to mention for the output filtering, but I mean, it's a Z490 Xtreme. We've seen this before. For the output filtering to improve the transient response, you know, even further, we have the tantalum polymer pulse caps from Panasonic. So, yeah. And I can't, like, I wish I could tell you that these actually work, but when I tested the Gigabyte Z490 boards, I do actually have, like, one Z490 Gigabyte board which didn't have any pulse caps. No measurable difference. So yeah, which really surprised me because like on earlier, like say Z390 Gigabyte motherboards, there was actually like a measurable difference between their higher end Z390 boards and their lower end Z390 boards in terms of transient response. But with Z490 and I guess the ISL 69, like the ISL 69269 and just overall, just other VRM adjustments, they managed to get the V-Core VRM to the point where it's just like, it is really, really good at transient response on, like, from the cheapest boards to the most expensive ones. So, yeah, with Z590, the only motherboards that I really want to test for transient response are, like, the Tachyon, because that totally that goes even a step further with the use of the pulse caps to try get better transient response, where the Tachyon doesn't the Tachyon just doesn't bother with the through-hole capacitors at all, because the through-hole capacitors are slow because they have a relatively high ESL. Also on the back of the board here, you can really see the iGPU power plane, which this is one of the, I think, benefits that some of the other manufacturers get from like not bothering with the iGPU power with iGPU power on their similarly like high-end boards, like say the Z590 Godlike, is just like you can dedicate more of the PCB to the V-Core power plane instead of having this like iGPU power plane running through here. And I do believe it's also present on the top layer of the board. But again, it's like, I don't think this really makes much of a, like, I don't think, like, on a board like this, that really shouldn't be making much of a difference. On lower layer count PCBs, it could actually be kind of significant. You know, you could actually get maybe a significant advantage by just ditching the iGPU phase and then running a V-Core power plane that just kind of goes through this area and then like this. Because like the iGPU power is in this area, and if you don't actually connect the iGPU to any kind of power delivery, well, you can just use that extra PCB space for more V-Core power delivery. But yeah, on the Z590 Xtreme, that's really not a concern. That's more of a potential optimization that might be beneficial on like 6-layer boards, whereas this is an 8-layer. It has absolutely no issues with powering anything you can put in the socket. So anyway, yeah, like this is unfortunately, like this is the most powerful VRM in Gigabyte Z590 lineup. The Tachyon might be slightly better on transient response, or maybe even significantly better on transient response. I haven't measured it yet, but in terms of sheer current handling capacity, this is the best Gigabyte has to offer, and like the transient response on it has been real, like on, you know, like the smaller version of this VRM that they had on Z490, the transient response was like great. So I they just added extra power stages. It's not going to affect the transient response in any negative way. In fact, it might get ever so slightly better, because if you turn on, because during really, really fast transients, depending on how the controller is set up, you can actually turn on all of the phases at the same time. So temporarily, the VRM ends up looking like a single like one phase. And you can get a slightly higher, like if you have more phases to do that with, you can get a slightly higher current slew rate when doing that. But I don't think that's actually, like, I don't think, like, I still don't think that would make a difference. Because on Z490, like, the Xtreme and the Master had the same transient response. And the Master had already, well, it was only 2 power stages less, but it was still, like, yeah, like, if there's a benefit to this in any way, then it's mostly just current handling capacity. Anyway, since we're already on the back of the board, let's talk about the memory topology. You'll notice that we have no memory pins going from the DIMM slots, and that is because Gigabyte is using SMT DIMM slots on this board. Theoretically, they can help a little bit with signal integrity for really, really high memory frequencies. In practice, on Z490, it didn't really seem to make much of a difference. Then again, on Z490, my 10900K just kind of sucks at memory frequency. So maybe with an 11900K, this will actually show up as being somewhat beneficial, because 11900Ks can run significantly higher memory clocks. Also, Gigabyte has some extra tantalum polymer capacitors for extra memory filtering, which I'm going to say, like, those don't do anything. They look cool, and on paper, they should improve the voltage regulation for the memory power delivery, but the thing is, DDR4 doesn't pull that much power, and the transient, like, it doesn't produce a lot of like violent transients. So this certainly doesn't hurt anything, but like you already get basically as good power delivery for DDR4 as you can with just like a basic single phase and some through hole polymer capacitors like you see over there. So this is just kind of like it is the extreme, right? So do like excessive capacitor configuration? Hell yeah, but I don't like this is not really achieving anything as far as I'm concerned. So yeah. Anyway, and then shielded daisy chain topology, as I mentioned, also 8-layer PCB. So this is like the best daisy chain configuration has in their Z590 lineup. It's shared with the Master also has an 8-layer PCB and the shielded daisy chain. However, the Master doesn't use the SMT DIMM slots, though. Again, it like at normal memory frequency, like at more normal memory frequencies, that's really not going to make much of a difference or any difference. So that's not really something to worry about too much. Also, the SMT DIMM slots don't automatically, like the thing is, just having SMT DIMM slots doesn't automatically make a board like better at memory overclocking. There do potentially need to be some adjustments made to the BIOS, which yeah, like it depends though. Like it really depends. So we'll have to see. Like I'll have to test what kind of memory frequencies are possible with the 11900K on this board versus some of the other motherboards that I have with the same 11900K. And like other motherboards from Gigabyte specifically, because if you compare it across vendors, then too many variables, and the SMT, like the effects of the SMT DIMM slots are probably just going to get buried under like differences in how the BIOSes are set up. But yeah, so like this is the best daisy chain memory topology that Gigabyte can, produce. If it actually leads to significantly better memory overclocking, I would say if you're really focused on memory overclocking, you would just get a 2-DIMM motherboard instead. Like an Apex or a Tachyon or an OC Formula or one of those boards. Because if you have 4 memory slots, you've already made you've already just kind of made the massive, like the 4 memory slots is a bigger problem than the pins on the DIMM slots themselves. So yeah, but this is still, like as far as daisy chains go, especially for Gigabyte, this is the best they can produce. It's just kind of like, I also like that's the thing with this board is like, there's a lot of things on this motherboard where it's like, technically this is better. Practically, I don't think it's going to make, like, it's not even, I don't think, it's like, well, okay, no. With 11th gen, I don't think it's going to make a difference. I don't know for sure. With 10th gen, it didn't make a difference. Probably because my CPU just doesn't clock RAM high enough, and I hit the limit of like the memory controller before I hit actually not even the limit of the memory controller. It's more like the limit of the system agent and the ring before I hit the limit of any of the like motherboard's memory topologies. Yeah. So that's kind of the thing. But with 11th gen, that might finally change since we do have the Gear 2 mode available, which allows much, much higher memory frequencies. So yeah, that is the Z590 Xtreme from Gigabyte. It's basically an exercise in massive excess of everything, right? Massive, like tons, like all the capacity. Well, I still think they should have used the same output filter as they have on the Tachyon. Like, admittedly, you can't get tantalum polymers rated for like 10,000 hours endurance like you can get the through-hole capacitors that they're using here. But, like, the tantalum polymers are just better in the first place, so... yeah, at the same time, I'd also be very surprised if it made an actual difference in transient response. But, yeah, like... I think the biggest... like... Again, this is just sort of Gigabyte like this is the everything motherboard. You've got all of the power stages, all of the capacitors, all of the, well, you don't have all of the buttons. The Tachyon has more buttons, but you've got your Thunderbolt, you've got your 10 gig, you've got your 2.5 gig, you've got your Wi-Fi 6E, which I don't like. Why is that still present on this motherboard? I do not understand. Like there's literally no space left in the rear IO for any more ports. You've got your actually you do have the addition of Safe Boot, but that's like most of Gigabyte, like several Z590 boards from Gigabyte have that. You have a postcode, voltage read point, everything. Like this is the Gigabyte Z590 or Aorus everything motherboard. It's just that you also probably don't need most of it. So, yeah. But a really cool board nonetheless. Like it's a cool board from like, oh, like, yeah, I don't know. It's not a board I would buy, but it's certainly like a cool board. On the basis of just like it does just kind of does do everything with questionable practical benefits of said everything being done. But yeah, so big thank you to Gigabyte for sending one of these over, as well as all the other Z590 boards that they sent over. We'll be doing PCB breakdowns of all of those as time goes on. And yeah, so that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both the Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you would check those out, especially since I recently bought a 6900 XT, and that really hurt. But yeah, so that's it for the video. Thanks for watching, and goodbye.